So today we're going to do integration by parts for a second day. And with this, we're going to need to do some mental integration. So if you look at this, if we want to integrate e to the negative x dx, we're going to need to, in our minds, we're going to need to let u be this negative x, which means I'm going to need a negative dx. And to pick up the negative dx, I'm going to have to multiply the outside by negative. So this winds up being negative and then e to the negative x plus some constant c. Why is that? So if you can't do it mentally, then you could always do integration by substitution. And what we're doing is we're letting u equal negative x, and then du would be negative dx. So we're going to need a negative with the dx to get that, to pick up that negative right there. We're going to need a negative on the outside. And that's where this negative comes from. It's from the negative on the outside that's compensating for putting this negative dx. All right. So similar here, cosine of 3x. So cosine of 3x. All right. So we're going to, if you think about this, we're going to let u be 3x. That means we're going to pick up a 3 dx. To get a 3 dx, I'm also going to need to multiply by 1/3. So what's going to carry over into our answer is not the 3, but actually the 1/3. So this is going to be 1/3, and the integral of cosine is sine. So this would be sine of 3x plus some constant c. And again, it's because if you couldn't do it mentally, what we're doing is we're letting u equal 3x, and then du would have to be 3 dx. And so to pick up this 3 with the dx, I'm going to need to multiply by 1/3, and that's where this 1/3 comes from. Similar here, e to the 5x, okay? So we're going to let u be 5x in our mind, okay? And then the derivative of that would be 5 dx. So to get the 5 dx, I'm also going to need to multiply by 1/5, and that 1/5 is going to show up in my answer. So this would be 1/5 e to the 5x plus some constant c. Again, it's because we're letting u equal 5x, and du would be 5 dx. Okay, so we're going to go back and review. Okay, so what do we pick to let our u be? Because we're going to need to, that's going to be the hardest thing, is like, what do we let u and what do we let dv that will allow us to use integration by parts? So once again, let's review. Okay, it's Lipit. And Lipit stands for logarithms, inverse trig functions, then polynomials, then look for exponentials, and then look for trig functions, okay? And this is what we let u equal, all right? And then the formula for integration by parts is u dv. The integral of u dv is equal to ultraviolet, so uv, minus the integral voodoo, right? So that's v du. So our u's and dv are going to be the two things that we're multiplying together. So in this problem right here, we want to evaluate the integral of e to the x cosine x dx. So if you follow this, we don't have any logarithms, we don't have inverse trig functions, we don't have polynomials. The first on this list is the exponential, and that's e to the x. So that's what we're going to let u equal. We're going to let u equal e to the x, and then dv will have to be everything else, so cosine x dx. And then du, the derivative of e to the x would be e to the x dx. And my v for my dv, I would have to integrate this, right? And the integral of cosine x is sine x. So evaluating this, this is telling us that the integral of e to the x cosine of x dx must equal uv, so that'd be e to the x sine x, minus the integral of v du, right? So that'd be sine x times e to the x dx, or I'm going to write the order as e to the x sine of x dx. Okay, so if you notice, we're kind of stuck again, right? Like, how do you integrate e to the x sine x? We're stuck. So the idea behind this is to let we're going to do integration by parts again, right? But with this one, and what we're going to do is we're going to let u equal, and we follow Lipit again, and it would have to be e to the x. And then our du would have to be e to the x dx. Something interesting is going to happen. That's why I'm going through this with you, okay? And our dv would equal sine of x dx. And so the integral, the antiderivative of sine x would actually be negative cosine x. So our v is negative cosine of x. So then replacing this with what this integral is, we would have, we want to write e to the x. Actually, we want to write this again. You'll see why in a minute. So integral of e to the x cosine of x dx is equal to e to the x sine of x minus, and then what we have to do is this integral, right? Because we're going to subtract that integral. Well, that integral, we're going to use uv minus integral of v du. So u times v, that would be negative e to the x cosine x minus the integral of v du. So that would be negative e to the x cosine x dx. Distributing this negative and also bringing this negative out, this one's going to become positive. So that's what I would do first. I would actually bring this out and make this one become positive. So this is e to the x, let's write this again, the integral of e to the x cosine of x dx is equal to e to the x sine of x minus, and I'm going to clean up what's here in the bracket, and that'd be negative e to the x cosine x plus the integral of e to the x cosine of x dx. And then what I'm going to do next is I'm going to distribute this negative with this term and with this integral right here. Okay, so then that makes the integral of e to the x cosine of x dx equal to e to the x sine x plus e to the x cosine of x minus the integral of e to the x cosine of x dx. All right, and let me slide it up so you can see that. All right, now because we're dealing with e to the x, right? The derivative of e to the x is just e to the x, and the integral of, and we're dealing with dv, which is cosine x, right? Changes to sine x, and then the sine x. These are gonna start switching back and forth between sine x and cosine x and sine x, and they're gonna alternate, right? So what happens is if you look at these are the same integrals, right? So here we have this one, and here we're subtracting it. Well, guess what? I can move this over to the other side. So what I can do is I can add the integral of, because this is an equation, because I have an equals, this is equal to, if I add e to the x cosine x dx to both sides, that's going to give me on this side 2 times the integral. So that winds up giving us 2 times the integral of e to the x cosine x dx is equal to e to the x sine x plus e to the x cosine of x. And then what we can do to figure out what this integral is, because that's ultimately what we're trying to do, is figure out what this integral is. And remember, the original integral started out this way, right? So we need to get rid of this too. Well, what we could do is multiply both sides of this equation by 1/2. And then we have to pick up the constant, okay? The constant of integration. So this becomes the integral of e to the x cosine of x dx turns out to be equivalent to 1/2 e to the x sine of x plus 1/2 e to the x cosine of x plus some constant c. And there's our answer to this integral. All right. So this happened, and this occasionally happens because we're integrating a trig function multiple times. So it's switching between like sine, well, and sine and cosine. So the derivatives and integrals fluctuate between sine and cosine. All right. And so, and then the e to the x also. So it's everything kind of working hand in hand together that's causing this to happen. Okay. Another type of problem that you're going to come across with integration by parts is called tabular integration or table integration. All right. Now, this is an interesting one, and it's because we're going to let u be a polynomial. So this what I'm going to show you only works when u is a polynomial. Okay. So I'm going to write that here. So only, we need to realize that this doesn't always work. Okay. It only works with polynomials. And I'll explain in a minute why. Okay. So we're going to let, by Lippitt, we're going to let u equal x squared. Okay. So these, we're going to let u equal f of x, which in this case is going to be x squared. And these are going to be derivatives of u. So the first column is going to be derivatives of u. And the second column, we're going to let be our dv. So in this case, our dv is going to be e to the x dx. All right. I'll just write it. Okay. So we're going to do integrals of g of x. We're going to call the dv g of x. So dv is equal to g of x. So in this case, it's going to equal e to the x dx. All right. So we're going to start doing this one. So we have x squared. We're going to start with x squared. That's our u. And then we're going to take the derivative of this, which would be 2x. And then the derivative of that would be 2. And then the derivative of that would be 0. Now, why this is going to work is because as we take the derivatives of a polynomial, we're eventually going to get to 0. And that's why this works, because the last one is going to be, we're going to be multiplying by 0. Okay. So this, what happens is this is my u and this is my du. The 2x is my du. So then the integrals of g of x, all right. So my first integral, or g of x, would be e to the x, and that's my dv. And then my v, so my integral of that would be e to the x, because the integral of e to the x is e to the x. And so what happens is this is just going to continue to be e to the x all the way down. Every single one we get to, it's going to be e to the x. All right. And then what happens is we're going to multiply this first one, this column. This is where the table comes in. We have a table here. It's going to be this one times this one. And we're going to add that product. And then we're going to go to this one and we're going to subtract. And then we're going to go to this one and we're going to add, and these are going to alternate, and it always starts out adding. And then the last one would be 0 times e to the x, and that one we're going to subtract. All right. I don't really care for this because it's like a trick. All right. Okay. But it does work. All right. So you can do it really fast because we would have to integrate multiple times to do this. Okay. So what happens is, okay, here's your u times v, right? Ultraviolet. There we go. So it's x squared times e to the x. So this is going to equal x squared times e to the x. All right. And then it's going to be minus 2x e to the x. So these are going to be the products, okay? And then we're going to add 2e to the x. And then the next one, we would be subtracting, and it would be 0 times e to the x. Well, that's just 0, so I'd be subtracting 0, so there's no point in writing that. So that's what happens, and that's why this works, okay? So then we have to recall that this is going to be plus a constant c. And so that's how you can integrate this. Now, again, this only works if you're integrating a product of two things, and one of them happens to be a polynomial, like this case, all right? And we're using integration by parts. Okay, so I want to do this actually with integration by parts, all right? So if you look at this really quick, if we have the integral of x squared e to the x dx, that's equal to, and again, we would let u equal x squared, and then du would be 2x, and then dv would be e to the x dx, and then v would be e to the x. So we pick up right here, we would have these two products, right? That'd be my ultraviolet. So x squared e to the x. And then minus the integral of voodoo, right? So 2x e to the x. So then our next time we're going to have to do it again, right? And this next one is going to be u is equal to, we're going to let it be the polynomial 2x, and then du would be 2 dx, and then dv would be e to the x dx, and v would be e to the x. So I'm going to just drop down my equals, okay, and this would be equal to x squared e to the x minus, and this would be uv, so u times v, so u times v would be 2x e to the x minus the integral of v du, so that'd be 2 e to the x dx. That 2 can come out, so this would be x squared e to the x minus 2x e to the x. This is going to become plus, and the 2 is going to come out. So plus 2, the integral of e to the x dx, and the integral of e to the x dx is just e to the x. So this becomes x squared e to the x minus 2x e to the x plus 2 e to the x, and then plus some constant c. And if we compare that to what we got from tabular integration, we got the same thing. I'll slide my paper down so you can see it. We wound up with the same exact thing. Okay, now this is a trick. Again, this is a trick. You got to write your derivatives of u until one of them until it gets to 0. So that's why this is working, because this one eventually becomes 0. That's why this only works with polynomials, because if you take the derivative of polynomials, eventually you're going to get to 0. All right, and these are all my integrals. Now, sometimes if it's not something simple to integrate, these are going to be hard to integrate, right? Okay. And then then we just had to do this twice, right? That's what happened. All right. So this is my uv, and this is my integral of v du, and we work it all out, and we wind up with the same thing. All right. I personally don't like it, but it's just because it seems like a trick to me. All right. So, but I wanted to make you aware of this one. So this next example, we want to integrate 4x cubed minus 3x squared times cosine x dx. Take a notice. This is a polynomial, right? So this is one where we could do tabular integration. All right. So we're going to let u equal 4x cubed minus 3x squared. All right. And then our dv would be everything that's left over, which is cosine x dx. And then this is going to be the derivatives of u. And this one's going to be the integrals of dv. And that's how I'd set up my tables. And we always start with u and dv in these columns, okay? So for this one, the first u is going to be 4x cubed minus 3x squared. The derivative of that would be 12x squared minus 6x. The derivative of that would be 24x minus 6. The derivative of that would be 24, and the derivative of that would be 0. So then dv is cosine of x, and then the integral of that. So the integral of cosine x would be sine x. The integral of sine x would be negative cosine x. The integral of negative cosine x would be negative sine x. And the integral of negative sine x would be back to cosine of x. So recall that we take, this is u, this is my u, and this is my du, and this is my dv, and this is my v. So remember, the integration by parts starts with multiplying u times v. So we're going to take these two, and we're going to multiply them together, and we're going to add that. And then from there, once you realize, okay, that first one's going to be adding, then they're just going to alternate. So then these two I would need to subtract. These two I would need to add. These two I would need to find the product, and I would need to subtract. And then I wouldn't need to do any more because it'd be 0 times anything else, right? So that's it. That'll be my last term right here, okay? So that means that the integral of 4x cubed minus 3x squared times cosine of x dx would equal these two multiplied together. Okay, so 4x cubed minus 3x squared times sine of x, and then minus, and it'd be 12x squared, and we would need to have parentheses around it, 12x squared minus 6x times negative sine x, or negative cosine x. So that's going to make this become plus cosine of x. And then plus 24x minus 6 times negative sine x. But then that's going to cause this to be minus, right? So you could do it all at once, all right? And then this would equal, and then this would equal, the last one would be minus 24 times cosine x. I shouldn't have put the equals here. Okay, so minus 24 times cosine of x, and then plus some constant c. All right, so I'm going to clean this up a little bit one more time. Okay, so this is 4x cubed minus 3x squared times sine of x. And this is b plus and 12x squared minus 6x cosine of x. And I'm doing this because I should have made this one minus. So minus 24x minus 6 times sine of x. And then minus the 24 cosine x plus your constant c. And that would be the answer to this integration problem. So for this next one, we're going to use inverse, we're going to look at inverse trigonometric and logarithmic functions. So this, we're integrating a logarithm function. So if you follow Lipit, like Lipit, the L stands for logarithms. So we're going to let u equal ln of x because it's a logarithm, okay? And so what would we let dv be then? Well, dv would be just this dx. That's all that's left, right? If you use ln of x, then my dv would be dx. So what's the derivative with respect to x of u? Well, that'd be my du, and it would be 1 over x dx. Well, what would v be? Okay, so v would wind up being just simply equal to x. All right. So that means the integral of ln of x dx is equal to u times v. So that's going to be x times ln of x minus the integral of v du. Well, that would be x times 1 over x dx. Well, x times 1 over x would just be 1. So this is equal to x ln of x minus the integral of dx. And that would just be x. So we wind up with x times the natural log of x minus x plus some constant c. And that's the integral of the natural log of x dx. All right. Okay, let's do an inverse trig function now. So here we have a differential equation, dy over dx is equal to sine inverse of x. If the graph of the solution passes through the point 0, 0. Now recall that this again is an initial condition, right? Okay, so to solve this, we're going to start with the equation, the differential equation dy over dx is equal to sine inverse of x. So I'm going to multiply both sides by the dx, and we get dy is equal to sine inverse of x dx, and then I'm going to want to integrate both sides. So the integral of dy is equal to the integral of sine inverse of x dx. All right, so the left side right here is going to become y equals, and how do we integrate this, right? So what's the antiderivative of sine inverse of x, right? We don't have that, right? So that's because we need integration by parts, all right? So we're going to let, okay, so following Lipit, we don't have any logarithms, right? We don't have any logarithms here. So the next in Lipit is I, inverse trig function. That's what we're going to let u be. So u is going to equal sine inverse of x, or arc sine of x. Okay, so then what's the derivative of sine inverse of x? Well, the derivative of sine inverse of x would be 1 over the square root of 1 minus x squared, and then dx. So recall that's the derivative, right? So we had to know the derivative of inverse trig function to do this. All right. So what's left over? If u is this part right here, then du would just simply be, or dv's rather, dv would simply be dx. So dv is equal to dx, and then that would mean v, the integral of dx, would have to be just plain old x. All right, so ultraviolet voodoo, right? So u times v, so it'd be x sine inverse of x minus the integral of v du. So if I multiply these, this would give me x over the square root of 1 minus x squared, or I'm going to write this as 1 minus x squared to the 1/2. And then times my dx. So take a look at this. If we let u, so now I'm looking at this, and how do I go from here, right? Because I don't recognize this as an antiderivative, okay? So then what you can do is you can let u be 1 minus x squared, and take a look at this. If we let u be this, then du would be part of this, right? And so we're going to do, this is integration by parts along with integration by substitution. So we're going to let u equal 1 minus x squared, and then du would be negative 2x dx. So I need a negative 2, right? So I'm going to multiply by negative 2 and also by negative 1/2. Or I could also just bring this negative in to the, because I need a negative 2x, right? So you could do it that way too. All right. So this would be y is equal to x sine inverse of x plus, and I'm going to let 1/2 times the integral of negative 2x over 1 minus x squared to the 1/2. And then dx. and hold on while I let students pass. So this becomes my u to the 1/2. All right, sorry about all the bells. Okay, here we go. So we're gonna let u be this 1 minus x squared to the 1/2. This is gonna become u to the negative 1/2. This negative 2x along with the dx, right, becomes my du, and I have this 1/2 on the outside. So this is y is equal to x times sine inverse of x plus 1/2, and this becomes u to the negative 1/2, and then du. And so because all that changed, now I can just apply, anti-differentiation to this, right? So this is going to be y is equal to x sine inverse of x plus 1/2 times, okay, so I'm going to have to add 1 and divide by that new power, right? So adding 1 to this, that makes u to the 1/2, right? Now I'm dividing by the new power 1/2, right? But a better way is to multiply by the reciprocal. So times 2 over 1, or just 2. And then I have the plus c, all right, my constant. So now what happens here is my 2's are going to cancel out, and I'm left with y is equal to x times sine inverse of x plus u to the 1/2, or u to the 1/2. Well, what is u? U is 1 minus x squared. So this would be the square root of 1 minus x squared plus some constant c. Okay, so now we got to use this initial condition, right? So we want to find the solution of the graph that passes through this point 0, 0. So we got to figure out this constant that causes that to happen. So the initial condition is 0, 0. Well, that means everywhere you see an x, you're going to replace it with 0. Everywhere you see a y, you're going to replace that with 0. So this would be 0 is equal to 0 times sine inverse of 0 plus the square root of 1 minus 0 squared plus your constant c. All right. So sine inverse of 0, well, what angle would give you a ratio of 0 for sine? Well, it'd be angle 0 times 0. So this is just all going to be 0 right here. So this is 0 is equal to 0 plus, and this would be the square root of 1, which is just 1 plus c. So that means 0 is equal to 1 plus c, or negative 1 is equal to c. And I just realized you can't see, sliding it up. My c is negative 1. All right, so that makes the equation y is equal to x sine inverse of x plus the square root of 1 minus x squared minus 1. Now the domain on this would have to be, we'd have to take a look at this. It can't be anything that would cause this under the square root to be negative. And also sine inverse, the x here has to be between -1 and 1. So that's it right there. My domain would be -1 to 1, including both. And that's it for that example.